Hi everyone! Thanks for tuning in. This is Andrea from Gradient 10. In this video, we set up and train a neural net using the S&P 500 companies description database available on Kaggle. The link is in the description box below. First, we select the data. Here we can see the original dataset along with train and validation files. We split the original dataset into a training set containing 95% of the data and a validation set with 5% of the data. We'll go ahead and select the training set for our net. Let's take a look at the data. The database has financial data for S&P 500 companies such as price to sales, relative strength index, and weekly, monthly, and quarterly performance. We are ready to design our neural net. In the toolbox, we'll select Net Module and click out on the drawing board. This brings out the Net Configuration dialog box. We will set the number of inputs to 8 to match the data and make the hidden nodes 10 wide. By default, there are 2 input layers and 3 output nodes. Then, we'll change the activation function from sigmoid to tanh. When we click OK, we get a net that we can place where we like on the drawing area. We now pull out the Properties menu. Next, we select the data for our input nodes. We select Total Debt to Equity, Price to Sales, Price to Free Cash Flow, Distance from 20-day Simple Moving Average, Distance from 50-day Simple Moving Average, Distance from 200-day Simple Moving Average, Distance from 52-week high, and Relative Strength Index. For our output nodes, we select Performance Week, Performance Month, and Performance Quarter. We attach the Properties box back over to the sidebar. Now we bring out the Pre-Process dialog box and we normalize all 8 input processing nodes. We'll normalize the output nodes from 0.2 to 0.8. Then we close the Pre-Process dialog box. Next, we click on the Train tab and we open the Validation Data dialog box. We click on the Validation Data File option, then we select our validation file. We'll now randomize our train inputs and save the file. We resize the window and we can see that we have 4 instances of NetDesigner open and ready. We close the Properties box and open and pin the Train Graph tab. We open the same net we just saved on the bottom left instance of NetDesigner. We now expand the upper right instance and we'll open the same net file. We'll copy and paste our hidden nodes until we have 32 nodes per layer. Then we auto-route the net. After selecting the bottom half nodes, we'll set them to rel U. We'll also set the output nodes to rel U. We'll save this new design and we'll reopen it in the bottom right instance. We close the Properties box and open and pin the Train Graph tab. We double-check our selections and make sure we're not automatically saving the files since each pair has the same name. We're now ready to train. Now we click the gears to start training. Then we left-click on the train graph to rescale the y-axis for all 4 graphs. We'll let the nets train for a while. After running for a while, we stop training. We can see that the smaller nets on the left didn't do as well on the training set, but did better than the larger nets with the validation data. We'll go ahead and open the output data sheet for the bottom left net and we'll save the data so we can plot training and validation outputs versus actuals. We'll also save the data for the bottom right-hand net. The graphs we see now show the 1-week performance for the small 20-node net data on the left and the larger 64-node net on the right. The trained data, actual, is plotted on the x-axis and the net output data on the y-axis. A perfect match would give us a straight line. We can see that the training data from the 20-node net output has a greater spread when compared to actual when compared to the 64-node net. The 64-node net actually has a pretty good match of net output to actual data. However, the validation data in fact matches better for the 20-node net as compared to the 64-node net, which has a much wider spread. This is often the case when neural nets are overtrained. When designing a neural net, we need to consider the validation set and training set accuracy trade-off. Generally, we can improve validation performance with more data. We now look at the 1-month performance data. We can see that the training set performed better in the 64-node net, but the validation is again worse. And finally, we look at the quarter performance data. For the 20-node net, the training data accuracy decreases as the prediction time increases, while with the 64-node net, training performance is still good. Validation performance is still better with the 20-node than with the 64-node net. Thanks for watching. We'll see you next time.